Hello everyone. In this video, I'm going to go through some of the basics of Java. Specifically, the topics I'm going to cover include variables, constants, strings, arrays, control flow, methods, random numbers, and user input. I'll touch on each of these topics. I'm going to use IntelliJ for the IDE for this project. I'll call my project Java Basics Fun. I'm going to create a new Java class. I'll call this Basics. So first things first, /** and / is a Javadoc comment. Javadoc is a nice tool that can be used to create documentation from your code. You don't have to put the 2 stars on the first line. This would work just fine. But the 2 stars denotes this is a Javadoc comment. Without the 2 stars, just a single star, it's a standard block level comment like you've probably seen before in C and C++. We also have 2 slashes for our single line comments in Java. All right, moving on. Let's take a look at what is public class basics. First off, every public type, and I want to qualify here that's an outer type, not a nested type, has to be in its own file. So for example, basics is a public type, it's a class, and it has to be in a file called basics.java. This name here has to match this name here because this is public. Let's talk a little bit more about public. There are 4 access modifiers in Java. The first one is pretty straightforward, public. This means accessible anywhere. The second one is package private, and this is if you don't use a modifier at all. So for example, if I took off public here, this would be package private. So package private means accessible anywhere in the package. I'm not going to talk about packages in this video, but feel free to take a look online if you want to learn more about packages. Next, there's protected, and this is the same as package private, plus accessible from any subclass, even if that subclass is in a different package. I'm also not going to talk about OOP, inheritance, or subclassing in this video, but feel free to use this as a springboard to do some Google searches and learn more about package private and protected and inheritance in Java if you're interested. And then the last one is private, and this means accessible only from this class. All right, next. Every Java program needs a main, and a main is a method that goes inside of a class. So here I have a class basics, and inside of the class, I can put in a main. So this is the standard header or signature for main. We know about public now. Let's learn about static. So static means class level. You don't need an object to invoke. I'm not going to go into too much of a detail about static or objects and invoking objects, but what this means essentially is we don't have to create a basics object, an instance of the basics class, in order to execute the main method of the basics class. It's static, so main can be executed without creating a basics object. I'll make one more note here because this is helpful if you're coming from maybe a Java background or another background where you've used static before. I like to put in here that static means know this reference. This is a reference to the invoking object, and in a static context, you cannot access the this reference. In Python, this is like self. All right, Void is the return type, main is the name of the method, string, hard bracket is the data type for the parameter args. This data type means a one-dimensional array of strings. And real quickly, args is a parameter to store command line arguments coming into the program. We're not going to talk about command line arguments in this video. All right, so we can print out args.length and see how many command line arguments are in this array, or essentially how many strings are in args. I'll run this real quick. All right, it says 0, so there are no incoming command line arguments to my program. This is also a great preview of arrays. All right, let's start with our first big topic, variables. There are 8 primitive types in Java. I won't go through all of them in detail, but I will list all 8 of them for you. So first is char. Here's an example of declaring a char. We can print out a char using system.out.println. We can also use the string concatenation operator in order to concatenate a string with a primitive. So I could put a nice label on this and concatenate it with my char using the string concatenation operator. I'll run this real quick. And there's my nice output. All right, the second one is an int. I won't do an example of it because it's fairly straightforward. The third one is a double, which is a double precision floating point number. I will do an example of this because I want to talk about how to format our floating point numbers. All right, so let's declare a double called myDouble, and let's declare it to math.py. All right, so some things to note about the math class. So the math class is in the java.lang package, which you get imported for free. So I didn't need to come up to the top of my program and put an import statement in order to access the math class. If you're familiar with C or C++, you might have to do a #include, a cmath, or a math.h in order to access something like pi from the math namespace or from the math header file, but here we get it for free because it's in the java.lang package. Pi is a static constant declared in the math class. We know it's a constant because it's in macro case, and it's also static because we don't need to create an object of the math class in order to access it. I'm going to print out myDouble real quick. All right, see how we have a lot of decimals for pi? Something that's kind of nice is being able to round our decimal numbers. If you've worked with C or C++, you might have used printf, something like this. This will work in Java. You can do system.out.printf. What I'm going to show you in this video is using the decimal format class, just as a little introduction to a reference variable. So everything we've been using so far has been primitives, but if a variable is not a primitive, it's a reference, and a reference is to an object. So let's see an example of making an object. So I'm going to use the decimal format class to make a decimal format object. Note that the decimal format class is in the java.text package, which we don't get for free, so we do need to import this. Import java.text.decimal format. The new keyword is used to invoke a constructor to create a new object. When we create a decimal format object, we can pass in a pattern for how we want to format our decimal numbers. So I'm going to use this pattern in order to get 2 decimal places to the right of the point and at least 1 digit to the left of the point. Now I'm going to print out my double formatted using df. And we should see 3.14 instead of this long set of decimal numbers here. All right, that looks good. Let's move on to our next primitive. Number 4, Boolean. There are reserved words in Java for true and false. You can see they show up in kind of a bold here. All right. The remaining 4 I'm not going to go into detail on, but I will list them here for you. So there's a short, which is usually half as big as an int. There's a long, which is usually twice as big as an int. There's a float, which is usually half as big as a double. And there's a byte. 1 byte usually used for binary purposes. All right, here's our next big topic, strings. So if a variable is not a primitive, then it's a reference. And a string is a class in Java. So anytime we're using strings, we're using objects. Variables can be references to those string objects. So let's make a string. We'll do a string literal for hello. That's my favorite word, my favorite string to use in coding. And of course, I can concatenate a string like a label to a string like my string. No problems there. Awesome. So because string is a class, we have access to several members of the string class. Some of these are really helpful. For example, let's take a look at myString.length and note that this length here is a method, whereas the length we saw earlier on line 22 for the array type, that length is a field. Notice how there's no open close paren up here on length. This is a field, this is state, whereas here, length for the string class is a method, it's behavior. So this is going to tell me how many characters are in hello, and we see there's 5. A few other useful methods of the string class you might want to use at some point, I'll list out here. So equals and compare to, these are helpful for essentially comparing two strings for equality or comparing them for order. Trim will remove any leading or trailing white space. Split will break up a string into substrings based on a token. For example, a row in a CSV file, if that's being stored as a string, then you might want to split up that string by a comma to separate it into its individual values or tokens. Another useful one is to Char Array. This will convert your string into an array of chars. And lastly, there are more, but lastly for the one I'll mention is Char@. Char@ is nice because if you're familiar with, say, C or C++, and you want to index into a string, you cannot use the hard brackets like you can for arrays with strings in Java. You'll have to use Char@ and then specify a zero-based index. All right, moving on to our next big topic, arrays. So I'm going to do 2 examples of arrays. The first one, I'm going to declare and initialize the array at the same time. So let's do an array of integers. I'll call it myInts. And I'm going to initialize this to a list of integers, just some random ones. Now, if I go to print out my ints, I'm going to get some strange output. If you're familiar with C and C++, you might look at this output and say, oh, that's the address, the memory address of the first element. That is not the case here. What's being printed is essentially a little bit of information about the object. So, for example, I can see before the @ sign some information about the type, right? The hard bracket tells me this is an array, for example. And then after the @ sign, I have some information about the identity of the object, like a hash. We're not too concerned with what this output is. It comes from objects toString, which, if you're interested, every class in Java, either directly or indirectly, is a subclass of the object, capital O object class. So we're not going to go into detail on this here, but I will show you how you can quickly print out your array so you can see the contents. So we're going to use the arrays class and its static toString in order to print out the contents of our array. So I'm going to do arrays, which is the name of the class, .toString. And if you see here, toString is overloaded to accept a bunch of different types of arrays. We see our primitives, right, like int, byte, char array, etc. And then down here, we see this capital O object array. So this is that kind of granddaddy superclass of all classes in Java, capital O object. So this here is an example of polymorphism because essentially every object, every class, every type in Java is a capital O object through inheritance. So this toString can essentially accept any array, which is pretty cool. All right, so we're going to pass in our array of integers, my ints, and we'll be able to see the contents of our array now. There it is. All right, the next example that I want to do is let's just declare our array and initialize later. So this time, let's use an array of object references. Let's do an array of strings. So I'm going to have a string array. I'll do this something like my friends. Let's say I have 4 friends. Now, here's a good time to talk a little bit about constants because this kind of bothers me a little bit to just hard code 4 in here. So what would be nice is instead of hard coding 4, let's use a constant called numFriends. So we need to define numFriends. So it's like a quick aside on constants. So use the final reserved word in Java in order to declare a constant. This is like const from C or C++. So we'll do final int numFriends is assigned 4. It also kind of bothers me to leave this here. I'm going to actually move this up to be a static member or a static field of my basics class. That way it has scope throughout my entire class instead of just after line 59. So I'm going to cut this and I'm going to move it up outside of main but still in the basics class and slap a static on here. Talking about the details of static is beyond the scope of this video, but I will make one comment here. Without static, every time perhaps we make a basics object, it's going to have its own numFriends variable, numFriends field. But if I put static on it, it makes it class level. So there's only one numFriends field that's essentially used by all objects because this numFriends field is static and belongs at the class level. One last thing I want to say about constants. Constants by convention use macro case. Just makes the code really readable. This is Pascal case where you update the first letter of each word. Types in Java use Pascal case. For example, I capitalize the first letter of my only word, in the name of my class, basics. But let's say I called this something like basics fun, then I would want to have F capitalized as well. That's Pascal case. There's also Camel Case. So Camel Case is used for identifiers. So like your variable names, my friends, for example, those are going to use Camel Case. If you follow the conventions, it can really make reading your code and reading other people's code that much easier. All right, that was our aside on constants. Let's head back to arrays. So I've gone ahead and declared my friends. Now I need to go initialize each string in my array. So my friends, sub 0, 0-based indexing. I'll just use some friends from friends. All right, here I've declared my array. Here I've initialized all of its elements. Now what I want to do is print out my array. Maybe print out how many elements are in my array. Note that here we're using a field, right? We're not invoking a method. There's no open paren, close paren here like there was for string. And lastly, let's print out the last element, just for good practice. This is going to be my friends sub my friends.length -1. Unfortunately, we can't just use -1 like we can in other languages like Python, but we can always get the length of the array and subtract 1 to get the index of the last element. And there it is. Joey is the last element in our array. All right, that's a quick crash course on arrays. Next, let's talk about control flow. So control flow in Java is just like C and C++. So we have our if, else structure. Let's do something like int x gets 5. If x is, let's say, less than 5, we'll print out x is less than 5. Else if x is greater than 5, let's print out something like x is greater than 5. Not being too creative here on this if, else structure, but it still serves its purpose. And else, this will be the case that x is 5. Switch statements are very similar to C and C++. I'm not going to do an example here just because switch statements, though useful, are not as popular. Many people choose to just use an if structure in order to solve a branching problem like this. Let's talk about loops really quick. In Java, we have a for loop, a while loop, and a do while loop. And these are the same as any C-style family of languages like C and C++. So I'll do a quick example of a for loop and a while loop. And a do while. Let's just do all three. All right, so let's print out the first 20 even numbers. So this would be 2, 4, 6, all the way up to 40. And I'm going to print them all on one line, just so my output isn't really huge. And in order to do this, I'll use system.out.print. Okay, the ln here means append a new line character to the end of the string, but just system.out.print won't put that new line character at the end. And then I will put a new line character in between each of my loops so that my output for each loop shows up on its own line and not all jammed together. So there's a for loop. We'll solve this same problem using a while loop. So let's declare an integer variable and say I is 1. So let's solve this just a slightly different way for fun. While I is less than or equal to 20, let's print out I times 2 and a space. You want to make sure you don't forget your progress towards your Boolean condition being false. So I'll do I++. So here we do have the pre and post increment and decrement operator in Java. And there we have the same output. And just one more, we'll do this same problem with a do while loop. So I'm going to initialize I to 2 to start over for my do while. And I'll say while I is less than or equal to 40, let's go up by 1. And this time, let's use a simple if statement and let's see if I is even. All right, so there's 3 different ways to solve the same problem using 3 different for loops. I'll also do one demo of a modification of the for loop. This is sometimes called a for each loop or a range-based for loop or an advanced for loop. I like to call it a for each loop, but I'll also put in here a range-based for loop. All right, so I'll type it out real quick and then I'll come back and explain what it does and how you should read it. Let's go through and use a for each loop to print out each element in our my friends array. Okay, so what this does is it iterates over each element in a sequence without using an index. So here I'm printing out each element in my array, but I'm not indexing into the array using an index or hard bracket subscript notation. Instead, I'm getting a reference to each of the elements or objects in the array. So here's a good way to read this. For each string friend in my friends, it really helps to read this colon as in. All right, moving on to our next big topic, we're now going to discuss methods. So methods is really just the Java term for functions. There isn't a distinction between a function and a method. Everything is a method in Java. So these are pretty similar to any programming language in the C family. The only thing maybe worth noting is you need to have the static keyword on your methods if they're not going to access the this context, and you need to have static. You need to not have static on your methods if they are going to access the this context. So really, let me write this down. Static methods for class level methods, no access to an invoking object. So really this means no this reference. And then non-static methods or instance level methods. So this would be access to a this reference, which is the invoking object. Like I said, I'm not going to go into too much detail here because the goal is to just cover the basics, not to talk about object-oriented programming, but it is worth looking into learning the differences between static and non-static methods. So all of the methods, or the one method I'm going to write here, this is going to be a static method. We're not going to need to make an object of type basics in order to invoke it. All right, so let's define a method that accepts two strings and returns true if the last character of each string is the same, false otherwise. So I'm going to define this static method outside of the main method, but still inside of the main class. I can't just have it floating out here. It needs to be inside of the class. So this will be a public static Boolean, that's our return type method, and I'm going to call mine has same last character. I like to name my methods so that they start with verbs because they represent behavior and action. We'll have two parameters, both strings. I'll call them first and second. We're going to write some good, robust code here. First, we're going to check to make sure that these are valid references. Null is a keyword in Java that refers to an invalid reference. So as long as first is not null and second is not null, then we have valid references. That means we can, access members of first and we can access members of second using our dot selection operator. Next, we want to make sure each string has at least one character, right? It has to have at least one character in order to have a last character. So if first.length is greater than 0 and the same for second is true, then we're safe to access the last character of each string. I'll do a simple comparison between first and second and their last character. I need to account for the case that either of these if statements evaluates to false. So I'm just going to put a return false here because if either one of these evaluate to false, then these strings are not going to have the same last character. All right, so let's call this and then run our code. There's two strings that have the same last character, so we should see true, and we do. Let's try this with an empty string. We should see false. These don't have the same last character. And let's try null, just to be comprehensive in our testing. And we see false. All right. So just one last thing to emphasize. This is a static method. We're invoking it without an object reference and a dot in front of it. That's a quick way to tell if a method is static or not. We also invoked a static method up here when we did arrays.toString. Now here it looks like we have an object reference and a dot in front of toString, but arrays is actually the name of a class. And it's quick to tell because it's capital A arrays, which is Pascal case. Okay, so toString here is also a static method. An example of a non-static method that we've used recently, .length. This is non-static. This is fairly quick way to recognize this is non-static is we do have an object reference, and because we named this object reference in Camel Case, it's easy to tell as well that this is an object reference, not the name of a type. And another one is right here, Char Array. So Char Array needs an object in order to invoke it. And here's our object reference right here first. Only two more topics in this video, which is getting quite long. I apologize for that, but we're covering a lot of ground in this video with the basics of Java. Next topic, random numbers. So one way to use random numbers in Java is to use the random class. So we'll create an object of type random. Note that this is not in the java.lang package, so we will have to import java.util.random. So go ahead and head up to the top of your code and import java.util.random. I'll just use a keyboard shortcut here for a project quick fix, which is Alt-Enter or Option-Enter. I'm going to call my random object reference randObject, or maybe randref. Create a new random object, and now we can go ahead and get random integers or random booleans from using randref. So let's do an integer first, because that's typically when we want a random number, we want an integer. So IntelliJ is going to give me a list of all of the different members I can access using my randref object. And two that are probably most useful are nextInt and the overloaded version of nextInt that accepts a bound. So I'll do this one. And I'll put in a bound of 6. So this is going to be 0 inclusive to 6 exclusive. So this is kind of like rolling a die if I were to add 1 to this. One thing to note, if you're looking at my code here, there's this label that appeared bound colon. This is a label that is inserted by IntelliJ. This is not part of my source code. So don't type bound colon. This is just something IntelliJ is putting in my code to make the code more readable. So there I got 2. Let's run it again. There I got 0. Ooh, 2 zeros in a row. Ooh, 3 zeros in a row. And there's a 5. Our last topic, user input. The demo I'm going to give now is going to use a class called Scanner in order to get user input from system.in, which is standard input from keyboard. You can get input using Scanner from a file as well, or a different file descriptor. But here I'm just going to show a simple case using system.in. Scanner is in the java.util package, so you will need to also go to the top of your code and import java.util.scanner. I like to call my scanner that I use for system.in, standard input, KB, short for keyboard, so I know I'm reading from the keyboard. Let's do 2 examples using KB. We'll read an integer from the user and we'll read a string from the user. And we're going to do it in that order so you can see a common gotcha that often happens when dealing with Scanner and the input buffer. So let's prompt the user for their favorite number. So we're going to assign to a local variable called favnum the return value from a call to kb.nextInt. kb.nextInt is going to go to the buffer, the input buffer, and try and find, starting at the beginning, an integer and return it. If the input buffer is empty, then our cursor in our program is just going to wait until the user enters in some values and then presses enter to send it to the keyboard buffer. I'm just going to simply echo back favnum. enter your favorite number, 23, and I echo back fav num. All right, so that seems to work pretty well. Now let's prompt for a string. Let's do something like enter your favorite place. So I'm going to go kb.nextLine. I like to use nextLine because it processes input. It processes characters until it encounters a new line, and then it tosses that new line out of the buffer. And remember, a new line ends up in your buffer when you type something and press enter. Enter is translated into a new line character. Enter your favorite number, 23, and then watch closely. I press enter for 23. I see my prompt for favorite place. It doesn't wait for any input from the user. Fav place apparently is an empty string, and then my program terminates. So real quickly, what's going on here is right here, line 131. This leaves the new line character in the buffer. Okay, it only grabs the integer out, even though I typed 23 and press enter. So the buffer had 23 and a new line character in it. Line 131 leaves that new line character. Then on line 135, we use kb.nextLine, which goes to the buffer and grabs everything until it encounters a new line. Well, there's already a new line in the buffer. There's nothing before it. So fav place is assigned the empty string, and that new line character is then removed from the buffer. So what we need to do here is a kb.nextLine, which is essentially going to flush out the new line character in the buffer from, I'll just say, next int. Okay, so the order at which we're accessing values from the buffer, from keyboard, does matter in what we did here. Okay, so typically I like to follow up a call to next int with a call to next line, just so my buffer's clear and ready to be processed for something else later. Let's try running this again. 23, and now it's waiting for me to enter in a string for my favorite place because the buffer is empty by the time line 136 executes. So I'll say my favorite place is Hawaii, USA. And there we go, it's echoed back. One more thing to note that might be useful using Scanner. Take a look at Hasnext. Hasnext is really nice if you're going to perhaps be parsing some complicated strings, reading in from system.in, or if you're using an input validation loop, you might want to use Hasnext in order to process tokens so that you only try to read something from the buffer if there's something to be read. I'm not going to do a demo here. It's a little beyond the scope of basics, but I do want to point it out because it's a method that's commonly used with Scanner. All right, so good job. You made it through a long video going through the basics of Java. We covered a lot in the video. The purpose is more for people who have a C, C++ background and want to just see some code to get started with Java hitting the ground running. Hopefully you learned a lot, and let me know if there's other topics in here that you would like to see in another Java video. Thanks for watching.